In this video, we're going to go over this warm-up question regarding a mole stoichiometry and mass stoichiometry problem. So we have aluminum reacting with hydrochloric acid to produce aluminum chloride and hydrogen gas. And we want to know what mass of aluminum chloride can be produced from the reaction of 60 grams of aluminum metal. So our first step is always to write a balanced equation for this situation here. So we're going to have aluminum, and it's solid, and it's reacting with hydrochloric acid, so HCl, and that is aqueous. And it's going to produce, and right, you can probably see it's already a single displacement reaction as per our previous units. And so we get aluminum chloride, AlCl3, and that should be aqueous, plus some hydrogen gas. And we're going to write down some information that we're given in the question. So we're given that the mass of aluminum that reacts is 60 grams. And actually, let's write that down to the proper number of significant digits that we have there, 60.0 grams. So you can see that we have 3 significant digits in this question, or 3 significant figures. And what do we want to figure out? What mass of aluminum chloride will be produced? So we are looking for this over here. So a reminder, when you want to find the mass, you need to do the mass is equal to the number of moles times the molar mass, and specifically in this case, it's the molar mass of aluminum chloride. And the molar mass of aluminum chloride can be determined using your periodic table. So you just need to find the molar masses of all the elements and add them together. So let's just go take a look at what we have. So we have 3 chlorines, which is 3 times 35.45, plus 1 aluminum, so 26.98. And we have 133.33 as the molar mass. So I'm just going to write that as a little note here that the molar mass of aluminum chloride is 133.33 grams per mole. So really, all we need now is a number of moles of aluminum chloride. We don't have that information given to us directly, but we can use the information from aluminum to find that. Remember, we can't do a mass-to-mass ratio. That does not work out. There's no direct route to go from mass to mass. So what we have to do is we have to convert this will be our second main step here, this mass here into moles. And so we can do that by doing that our moles is equals to our molar mass, or to our mass over the molar mass. And so the mass given to us is 60.0 grams divided by the molar mass of aluminum, which once again, just to show you where to find it in case you don't remember, is 26.98 grams per mole. So divided by 26.98 grams per mole. And so the units of grams cancel out, and you're left with moles at the end. And so we get 60 divided by 26.98. And that leaves us with 2.223869533 moles. Now, you don't have to write all those down, but don't round too early. If you round too early, then all your answers are a little bit more off than they should be. So I like to keep everything in my calculator. So that this number I wrote down here for aluminum is still in my calculator right now. And so what I'm going to do next is I'm going to write a mole ratio for what I'm comparing, aluminum to aluminum chloride. So one thing you'll notice that I forgot to do right off the bat is I didn't balance my equation. So if I continued like this, and I made a mole ratio with it not being balanced, my answer would have been off. So let me go back and make sure my equation is balanced. So my first step should really be to balance the equation. Balance it. So 1 aluminum, okay, everything's off here. Chlorines are off, so I think I need to put a 2 here. That will make 6 chlorines there, 3, and a 2 here. So 2 aluminums, 6 chlorines, 6 chlorines, 6 hydrogens, 6 hydrogens. Now we're balanced. And so now we can write a ratio that will actually work out. So we have 2 aluminums for every 2 aluminum chloride. And that can be simplified to a 1-to-1 ratio. 1 aluminum for every 1 aluminum chloride. And you could even write it as a fraction or as a conversion factor. So you can say that for every 1 aluminum, there is 1 aluminum chloride. And you can apply this conversion factor in the next few steps we'll be doing. So our fourth step is to now use the moles of aluminum to find the moles of aluminum chloride. And so we're going to go ahead and do that. We're going to take our moles of aluminum, which was, so moles of aluminum chloride is equal to the moles of aluminum, so 2.223, and you can continue 869.533 moles times, and you know what, I'm going to put moles of what, because I'm going to show you unit cancellation, so I just want to be specific here and put which moles I'm discussing. Let me just get my ink to work again. There we go. Moles of aluminum multiplied by my conversion factor, where I want aluminum at the bottom. So 1 mole aluminum, and then at the top here, 1 mole aluminum chloride. And you would have noticed it's a 1-to-1 ratio. So even without doing this math, you would figure out that they should be the same number of moles. But we're just doing this to show us our unit cancellation, and so we can cancel those out there. And so we get that we get 2.22, so on and so forth, times 1 divided by 1, which is really just times 1. So our moles of aluminum chloride are equal to the moles of aluminum, moles of AlCl3. So now all we have to do is convert that into mass by doing that, the number of moles times the molar mass of the AlCl3. We're done with all the aluminums now. We're just focusing on aluminum chloride right now. And so that's going to be our moles that we had up here, 2.223869533 moles, multiplied by our molar mass of aluminum chloride, which is 133.33 grams per mole. Cancel moles out, and you get your mass. And I ran out of room here, but your mass is equal to, so times 133.33, and we get about 296.5085 grams. And then you can make a therefore statement. Therefore, the mass is approximately, and I'm going to round to my sig figs here. We wanted 3 sig figs, so normally we'd round to 296, but because after the 5 there's numbers, we're going to round to 297. So 297 grams, that is 3 sig figs. And I'm going to put of aluminum chloride. So I set up my balanced equation. I wrote all my information in. I found my molar masses. I used the moles of aluminum to find the moles of aluminum chloride. I could not use the mass of aluminum to do that because there's no direct route. To do that, I had to, again, convert and then find my mole ratio. Once I found my moles of aluminum chloride, I was able to convert it to mass by multiplying by its molar mass, and then I made sure I rounded to a proper number of significant figures. In the next video, we're going to take a look at how to solve part B.